Hi there, and welcome to this lesson. In this lesson, we'll be learning basic trigonometry. Okay, so basic trigonometry, and on the basic trigonometry, we'll be learning about trigonometric ratios. Trigonometric ratios. Now, as the lesson progresses, anything you don't understand, be sure to contact your tutor, who would be more than happy to help. And yes, let's jump right into the lesson. So, trigonometric ratios. Now, what exactly are trigonometric ratios? Now, trigonometric ratios relate the angles of right angle triangles to the length of their sides. So, trigonometric ratios relate the angles of right angle triangles to the length of their sides. Now, you have a right angle triangle like this, okay, and we have an angle here we call theta, and we're going to call it, we usually refer to this as the reference angle, okay. And this angle is actually very important. Reason being, basically, when you're labeling the sides of a right angle triangle, if you recall, you have the longest side as your hypotenuse, okay, and then you have the other two sides, your opposite and your adjacent. But in truth, the opposite is and the adjacent, they're not fixed, okay, so they vary from time to time, because the position of the opposite depends on where your reference angle is, and the side opposite your reference angle is always the opposite, and then the side adjacent to your reference angle is the adjacent. Now, similarly, if you had a triangle like this where you have your reference angle at the top there, longest side remains the hypotenuse, but in this case your opposite would be the horizontal and your adjacent would be the vertical. Okay, something very important that you need to take note of. And now let's talk about trigonometric ratios. Now, trigonometric ratios relate the angles of right angle triangles to the length of their sides. Now, I have this triangle here, okay, and I have this theta, my reference angle, and basically I label the three sides O for opposite, A for adjacent, and H for hypotenuse. And basically I'm going to tell you that we have three very important trigonometric ratios. So we have sine, we have cosine, and we have tangent, okay. And basically these, like we said, relate the angles of the right angle triangles to the length of their sides. And we have this very important acronym that we use to remember this, and it's SOHCAHTOA, okay, so SOHCAHTOA. And basically what this means, what this tells you, is that so is for sine, so SOH, sine of your angle theta equals O over H, okay. So SOH is sine equals O over H. So sine actually relates, is the ratio of the opposite and the hypotenuse. So sine theta is O over H, okay. And then similarly, cos theta is A over H, and then tan theta, TOA, is O over A, so the opposite over your adjacent. And that's it, pretty much all you need to know. And now we just go ahead, I have this triangle here, I'm just going to go ahead and identify the sine, the cosine, and the tangent of the angle theta. And basically the sine of theta here, sine theta, equals the opposite divided by the hypotenuse, and in this case we have 3 over 5, which gives us 0.6. Now similarly, the cosine is the adjacent over the hypotenuse, so 4 over 5 in this case, so 4 over 5, which gives you 0.8. And then tan theta is O over A, which gives you 3 over 4, and in this case we have 0.75, okay, so 3 over 4, the opposite over the adjacent. Now, what if you're looking to solve for theta? Because I told you that the trigonometric ratios relate the angles of right angle triangles to the length of their sides. So if you're looking to solve for theta, quite simply, you can basically use sine, okay. So sine of theta we've established is 0.6, and basically I tell you, if you're looking to find theta and you're given sine of theta, so you have sine of theta equals 0.6, what you do is you find the sine inverse of 0.6. so theta equals the sine inverse of 0.6, and you can actually do this using a calculator. So sine inverse of 0.6 would give you 36.87 degrees, okay, so 36.87 degrees. And that's pretty much it, okay, pretty much all you need to know. Okay, here's another one. Okay, we have, and in this case we're given the angle, okay, and we're looking to solve for the side. Okay, so we're given the angle, we're looking to solve for the side, and basically in this case we have the sides we're working with. Basically we're looking to solve for the adjacent, we're given the hypotenuse. And when you have a situation like this, the first thing you need to do is you need to identify the trigonometric ratio that relates the adjacent and the hypotenuse. Because you have the adjacent and the hypotenuse, find the trigonometric ratio that relates the two, and we know that that trigonometric ratio is cosine. Okay, and then what you do is you find, basically you have that the cosine of 60 would equal the adjacent over the hypotenuse, so x over 7 in this case. And basically you have that x, when you cross multiply, x would equal 7 times the cosine of 60. And if you work your calculator, you'd find that the cosine of 60 is actually 0.5. okay, and then you have that x equals 7 times 0.5, x equals 3.5. Very simple, very straightforward. Now let's go ahead and do some examples. Example 1. Example 1, we've been asked to solve for the lettered angle in the right angle triangle below. Okay, so basically in this case we have angle alpha, okay, and we're given two sides, the opposite and the hypotenuse. Okay, and given the opposite and the hypotenuse, the trigonometric ratio would be applied in this case is sine, because sine is the trigonometric ratio that relates the opposite and the hypotenuse. Now sine of theta equals O over H, okay, and then we have that O in this case is 4, H is 5, which tells you that sine of theta equals 4 over 5, which is 0.8. And then to find alpha, not theta, alpha, you find sine inverse of 0.8, and this gives you 53.13 degrees. Very simple. Okay, so you're looking to find the angle, you're given two sides, you need to find the trigonometric ratio that relates those two sides. So in this case we have the opposite and the hypotenuse, and basically the opposite and hypotenuse are 4 and 5 respectively. We have that sine is our trigonometric ratio that relates the opposite and hypotenuse, and sine alpha equals 4 over 5, sine alpha equals 0.8, and we have that alpha is the sine inverse of 0.8, and if you find the sine inverse of 0.8 using the calculator, you would end up with 53.13 degrees. Very simple. Now let's do another one. Example 2. And example 2 says solve for the lettered angle in the right angle triangle below. Okay, and basically we have beta, okay, and we're given two sides, okay, and in this case we have two sides. Actually we have the opposite and the adjacent. Now can you tell which is which is the opposite, which is the adjacent? I tell you the opposite here is 10. Okay, very careful, you need to be very careful about that. And then the adjacent is 6. Okay, and basically the trigonometric ratio that relates opposite and adjacent is tangent. So tan of theta equals opposite over adjacent, and then we have our opposite as 10, our adjacent as 6. And we're just going to go ahead. So we have tan of beta equals 10 over 6. You find 10 over 6 and you have 1.667, and what you have in the end is you have beta equals tan inverse of 1.667, and you do that using the calculator, you'd end up with beta as 59.04. okay, another example, example 3. In example 3, we've been asked to solve for y. So we have solved for the lettered side in the right angle triangle below. Okay, and basically to solve for the lettered side, we're working with the hypotenuse and the adjacent, and we need to know which the hypotenuse and the opposite. Very important, the opposite, not the adjacent. Our angle is up there, so we're looking for the trigonometric ratio that relates the opposite and the hypotenuse, and we know that's sine. So sine of 63 in this case would equal the opposite 11 over y. So sine 63 equals 11 over y, and you have that y equals 11 over sine 63. When you rearrange what you have there, and basically have y sine 63, if you do your calculator, you have 0.8910, and you have that y in the end is 12.34. Very simple. Now, one final example. Okay. Ooh, very interesting looking example. So we have a triangle here. We have a triangle with a triangle inside, and let's just go ahead and solve this. Okay, so we have this triangle. We have 25 degrees. We have 7, and we have two legs which we believe to be equal. Okay, so we have C and D equals B, CD equals BD. Okay, and I'll tell you, or DC equals BD, and I'll tell you that to find DC, basically we have that tan DC, the opposite of that triangle, divided by the adjacent 7 would give you the tan of 25. So DC equals 7 times 25. You have that DC equals 3.26. Okay, now since DC and BC are equal, since DC and BD are equal, you can tell that BC would be 2 times DC. So the length of the full triangle there would be 2 times the length of DC. So we have that BC is 6.52. Okay, and then with that we can go ahead and solve for the big angle there, which would be 25 degrees plus gamma, and we have 25 degrees plus gamma equals tan of 25 degrees plus gamma equals 6.52 divided by 7, and basically we have tan of 25 plus gamma equals 0.9314, and you just go ahead and solve all of that, and you should end up with your answer. Basically, when you subtract from 42.97, gamma is 17.97 degrees. And that should bring us to the end of this lesson. Okay, you can go ahead now and solve questions on the worksheet. Bye for now.